we want to construct a box whose base is 4 times the base width. So I've set x as the base width because that's my starting point, and then the length is 4 times whatever that is. Okay, we've got a box, so I've still got to consider the height, and that's because the volume, okay, is 60 meters cubed. So I can say that 4x times x times height is going to be equal to 60. Okay, so that's a volume thing, but of course I don't want more than one unknown, so I've got to do something about the h. So in this case I can say that 4x squared times h is 60, therefore h is 60 over 4x squared. So there's my first step, and now I can use that to get stuck into the thing which is to do with the cost. Okay. The reason why I'm focusing now on cost, because in the question it says determine the dimensions that will minimize the cost to build the box. Therefore, my function that I'm looking for is about cost. So I've got two pieces of information about that. So the top and bottom cost 12, and the sides cost 7. Okay, so I'm going to set up an equation to deal with that. Okay, so let's take each one and let's just sort out each thing separately first. So the area of my sides. So if I do top and bottom first, because they're my easy one. So I've got 2 lots of, because it's the bottom and the top, 4x squared. So it's 4x times x gives me that base, and it also gives me this top. So I've got 2 lots of those. So that will be 8x squared. And of course, they cost $12 per meter squared. So I can do 12 times that. So that's a meter squared value, so $12 per meter squared. Okay. I've got to add to that my n's, which would be x times h, so that will be x times 60 over 4x squared, and I've got 2 of them, so I've got 2 times 60x over 4x squared, because that's the x times 60 minus 4x squared, right? Which of course can be simplified. I can cancel out the x and x there, so now I'm left with 2 times 60 makes 120 over 4x, but of course 120 over 4, so I'm going to simplify that as well to, that will be 30. So I'll just put my 30 on the top, 30 over x, and the cost of one of those sides is 7. So I've got 7 times that, and of course then I've got the other longer sides, so that will be plus another 4x, I do it up here, plus 2 lots of, again, 4x times 60 over 4x squared this time. Now, this one is a little bit easier to simplify because the 4x here cancels with the 4x squared, so I'm left with only the x. So then I've got 2 lots of 60 over x. So again, that's 120 over x. And this time, again, it's 7 times that for the cost. So just to clarify that, I've got 2 lots of 4x squared, which would be this base and this top. Okay. I've got 2 lots of x times 60 over 4x squared, so that's this end point here and the end point here, so that's those two done and simplified. And then I've also got 2 lots of, oh now it's this one and then obviously that backside, which will give me this lot here. So I've got all those sides covered, and just to check the costs again, so we've got 12 meters squared for the top and bottom, and we've got 7 meters squared. So we should have this 12 meters squared for those two, top and bottom, and we should have $7 per meter squared for the other sides. Okay, so that is our cost function. So I've got cost equals, and of course I can simplify that at this stage. So 12 times 8 is 96x squared, okay, plus 7 times 30 is 210 over x, plus 840 over x. Now these two fractions can be simplified, so I've got 96x squared plus 1050 over x. So the question was, now we've got to find the minimum cost, so we're going to look at having to again solve f dash of x equals 0 to find where we have a minimum. Okay, so I'm going to find dc dx. Okay, so maybe I should just rewrite this bit especially, so that will be x to the minus 1. So when I differentiate, I've got 2 times 96, which is 192x, and then minus, because obviously this comes, and then 1050 x to the minus 2. Okay. Or dc dx equals 192x minus 1050 over x squared. So I am looking to solve 192x minus 150 over x squared equals 0. So in this case, we are going to use our calculator. So I have my calculator here. I'm going to put my function in. So I've got 192x minus 1050 x to the power of minus 2. Can do it like this way. Okay. If I want to graph that, see what it looks like. You can see I've got very clearly, if I'm going to find a 0, that's very clearly at this point. So on my calculator, by the way, just in case you're wondering, my window settings are like that. Set up from a previous question, get lucky. Got to think what numbers would be applicable in this case. So y being, values for cost, got to make sure they're reasonable numbers. So if I'm going to find this 0, I'm going to go second at calculate. 0 tells me to go to the left of it, so I'm going to go all the way to the left. So once my point's at the left, I'm going to press enter, go to the right of that point, enter, guess, go slightly near it, press enter, and I get an answer of 1.762. So 1.762. Okay. So we just need to make sure that we're actually answering the question, because the question says determine the dimensions that will minimize the cost of the box. So I know x, so that's one dimension, but then I've got 4x, and I've got the 60 over 4x squared to deal with. So we've got 4 times 1.762, 7.048, and then I've got to do, I'm going to use my fraction and do 60 divided by 4 times 1.762 squared. Let's enter, and I've got 4.831. 4.831. So there I have my 3 dimensions of the cuboid, which should minimize the cost. So obviously a big point here, and to remember from previous examples, you go back and you make sure you have read the question and done what it's asked of you to do. So we need to be very, very clear when it says determine the dimensions that will minimize the cost of the box. And we also just need to check whether it wants us to give evidence that it is a minimum. It doesn't really in this case, but potentially what we could do just to add to our answer is show that we had a sketch and we had our graph and we're finding this point. Okay, so that was our dc dx. Okay.